Today we're going to be covering the definition of a derivative. So the definition of a derivative is the limit as change of x approaches 0, then f(x) plus change of x minus f of x all over the change of x. So that's the definition. So how we're going to use that is we're going to get a function. Let's just use an easy one right now. F of x equals x plus 2. Alright, so what we're going to do is we're going to take this function and we're going to plug it into the definition to get our derivative. Just to mention it, a derivative is the slope of a tangent at a certain point. So, alright, so the limit, so this is our definition. Always make sure you remember you write that down when you're doing a problem. And we're going to plug in x plus 2 into this. So, the limit as change of x approaches 0. And then, so it's going to be x plus change of x plus 2 minus x plus 2 all over change of x. Alright, now that we have that, we're going to just distribute and have it all out. So the limit as change of x approaches 0, x plus change of x plus 2 minus x minus 2 all over the change of x. Alright, so now we have things that we can cross out. So we have the plus 2, minus 2, the negative x, and then the x, right? Alright, so we're going to cross those out, and we're going to get the limit as change of x approaches 0, change of x over change of x. And if you simplify that, that equals 1. So your answer, the derivative as x plus 2 is equal to 1. And that makes sense because the slope of x is just 1 if you were to graph that, meaning that your derivative is 1, and you can just check that easily. Now let's try another function, but let's make it a little harder. Alright, so let's do as f of x approaches 6x plus 4. Let's use that. Okay, so let's write the definition. Always write the definition. The limit as change of x approaches 0. So, and it's f of x plus change of x minus f of x all over the change of x. Alright, sorry, that's kind of messy. Alright, so let's plug that all in. So you're going to get the limit. Always make sure you don't forget to write the limit as x approaches 0. So it's going to be 6x plus change of x plus 4, minus 6x plus 4 all over change of x. Alright, so the limit, and we're going to obviously distribute all that out and get it all simplified and get it all easy to read. So 6x plus 6 change of x, because, distribute that. And then plus 4 minus 6x minus 4 all over change of x. So now can you see what we can cross out here? We can cross out the plus 4 minus 4 plus 6 minus 6. And we're left with limit as change of x approaches 0, 6 change of x all over change of x. And if you cross out these, because they both are top and bottom, you're going to get 6 as your derivative. So your slope is 6, and that makes sense because rise over run, 6x plus 4, the y doesn't do it. Their y-intercept doesn't do anything to affect the slope or the derivative of yeah, so that's pretty much it. But now let's try something a little more difficult. Let's do f of x equals x squared plus, oh, well, maybe we can do minus 3. Alright, x squared minus 3. So, obviously, don't forget to write your definition, limit as change of x approaches 0, and fx plus change of x. Sorry, I know this is getting repetitive. F of x all over change of x. Alright, now you're going to get, just plug it all in, and you're going to limit as change of x approaches 0, x plus change of x squared, make sure to square all that, minus 3 minus x squared minus 3, all over change of x. Alright, so the limit as change of x approaches 0 is x plus change of x. Well, sorry, it probably would be best to factor this all out, like get it all out. It's going to be x plus change of x times x plus change of x. I'll do that over here, down here, so it's easy to explain. X plus change of x, x plus change of x, and you're going to factor, so it's going to be x squared plus 2 change of x, x, oops, I should probably write it x change of x, because then it, yeah, that makes sense, x change of x, yeah, plus change of x squared minus 3 minus, oopsies, I don't really have a lot of room, plus 3, don't know, yeah, okay, so just remember that's 3 right there, all over change of x. And now let's see what we can cross out. We can cross out the x, change of x, oh, I'm wrong, sorry, you can't cross out that, oopsies, let me fix that, plus change of x squared, my bad. You can cross out the minus 3 plus 3, cross out the x squared minus x squared, right? So now you're going to be left with, I'm going to erase this now because we don't really need it, I just wanted to show how to factor that all out. And then, so you're going to get 2x change of x plus change of x squared all over change of x. So, can you see right here on the top, you could, there, in both parts of the problem, on the top, on the numerator, you can take out the change of x. So right here you would take out the change of x, and you're going to be left with 2x plus change of x all over change of x. Oh no, I'm running out of room. Alright, so now you have a change of x at the top and a change of x at the bottom. You can just cross them out, and you're going to be left with limit as 2, I'm not going to, don't really have a lot of room, so I'm just going to write 2x. Just remember it's the limit as x approaches 2x plus change of x. And when you have that, you're going to take the limit, you're going to take the change of, so you're going to take it to 0, you're going to plug that in to 2x plus 0, and you're going to be left with 2x. So your derivative is 2x. And that's just how it works, and that's just how easy it is. Alright, well, that is all for our lesson. Thank you.